Hey guys, welcome to Unit 8A, Lesson 3. Our topic today is derivatives of inverse functions. So pause the video and try the warm-up. The warm-up says, find the inverse for each of the following functions. So remember, whenever we talk about inverse functions, I want to do a little bit of stuff here. So I'm just going to go to my basic log function. This is my log function, right? Logs and exponentials are, we say, inverses. Why are they inverses? Because inverse functions are a reflection over the line y equals x. So that's how you can do it graphically. Basically, your x and y are switched. So that's what happens with your coordinates also. So if you're given a coordinate and you want to find the inverse, this is how you write that, to the -1. So all you do is switch the points. 6, 3, 2, -1, and 7, 4. So now when you are for a equation, if you're given an equation, you want to find the inverse, you switch the x and y. That's your first step. So it'll be x equals 5y minus 8. Remember, f of x is the same thing as y. So I switch the x and y, and now you solve for y. So it'll be x plus 8 equals 5y. So y is equal to x plus 8 over 5. Always use your function notation, x plus 8 over 5. So that was your inverse. And if I was to graph both of these, they will be a reflection over the line y equals x. Okay, so another thing that we need to remember, things to remember about inverses: if f of x is a one-to-one function. Do you remember one-to-one function? That every y is unique to x. So then it will then it will have an inverse function defined by f inverse of x, or I can use a different function letter. So again, I want to quickly go over one-to-one function. And so if you have a function, I'm going to go to my parabola. This is my parabola. So if I did a vertical line test, that was to check whether a given graph is a function or not. So if it touched the graph only once, you know that graph was a function. But if I did a horizontal line test, that checked whether it's a one-to-one function. So here, if you look at the green line, it's crossing my graph at 2 points. So this function is not one-to-one function, meaning its inverse will not be a function also. So let's talk more about this. A function g of x is an inverse function of f of x if, this is composition, f of g of x equals g of f of x. So if you did composition of each other and that equals x, then you know these are inverse functions. This means that the domain of f is the range, and that's what we did for do now question, of g, and vice versa. Basically, what can I say? X and y get flipped because it's a reflection of the y equals x line, right? So the graphs of the function f of x and its inverse, f inverse of x, are reflections of each over the line, which we talked about it, y equals x. So what if we wanted to find the derivative of an inverse function? What will we do? So let's do this exercise, and this will make more sense to us. Oh, I can't scroll down. Oh, this is here. Okay, so we are given a function cube root of x. So it's asking us to do, there is a point on the graph of f where the y coordinate is 2. What is the x coordinate at that point? So if my y coordinate is 2, so I'm going to just set my equation equal to 2, and I'm going to solve for x. How do I undo that? I'm going to cube both sides. So 2 cube is, I'm going to cube both sides. So 2 cube is 8, is equal to, these cancel, so x is equal to 8. So your point is what? your x is 8 comma 2.
Part B. So it's asking us to find f prime of x. So this is my f function. Can I rewrite it as x to the 1/3 power? So I'm going to find the derivative of this. So I'm going to use my power rule. My 1/3 comes in front, and x 1/3 minus 1 is 2/3, or negative 2/3, or I can rewrite it with positive exponents only. So it'll be x to the 2/3. So this is my f prime of x. Now it's asking us to evaluate. Again, remember, evaluate means you're going to substitute something into this function. There is a word value hidden in evaluate. At the point found in part A, our point was 8 comma 2. So I want to find my slope. Basically, that's what it is at point 8 comma 2. So f prime of 8 would be, all I'm doing is substituting 8 in for x. So if I was to do this, I'm going to do this on the side. So basically, how do you do this math in your head? How do you simplify it? Take the cube root, because 2 is your power, 3 is your root, right? So take the root first. So cube root of 8 is 2, and 2 square is 4. So that's how you do it. You can do it the other way around also. Do the power first, because it's easier to work with smaller numbers than larger numbers, right? So 8 squared is 64. Cube root of 64 is 4. No matter which way you do, you'll get the same answer. So it's 1 over 3 times 4, which is 1/12. So that's my slope basically. Now I want to find the inverse of x. Remember, inverse means switch the x and y. It's the reflection over the line y equals x. So my function given to me is y equals x, cube root of x. So I'm going to write it, switch the x and y. So x is equal to y to the 1/3 power. Can I rewrite it like that? Or cube root of y is also fine. So now how do I get rid of an exponent? You do multiply both sides, or raise both sides to the reciprocal. So which is what? 3. So y to the first. So I'm going to rewrite with the notation so that it's much clearer. Otherwise it can get a little confusing with x and just x and y's in there, because there are a lot of x and y's. So now find f inverse prime of x. So I want to find the derivative of this. I'm going to just change colors so it's easier. So that would be just 3x squared, right? Use your power rule. Now what point on f inverse corresponds to the point 8, 2 that lies on f? Remember, the inverse and the original function, their points are switched. So if 8 comma 2 is the point, it would be 2 comma 8 on the inverse. So now evaluate f inverse prime of x. So I want to do f inverse prime of 2, right? Which actually happens to be the original y. I don't know if you've noticed that. Which would be, so substitute in there. So it's 3 times 2 square, which is what? 2 square is 4. 4 times 3 is 12. So here's a big revelation. Now the last thing it's asking us, what do you notice about the answers to C and G? So that's just G. And let's zoom out and find our C. Oh, C is here. I'm going to highlight them so it's easier. So what do you see? What do you notice about these? That they are reciprocals.
So what can I conclude from that? Oh, here. So let f and g be inverse functions such that f of g of x equals g of f of x equals x. That is another way of saying that these two are inverses, because if I did the composition, I will end up with x for both of them. With f of a equals b and g of b equals a, right? Your a is your x and b is your y. And when you're doing the inverse, they get switched around. So g and the derivative of g of b is 1 over the derivative of f of a. So now what is a? These are your original. This is what I want you to understand this. This is the original x, and this is the original y. Okay, so that's what it is. So this is what we're going to be using it in the entire lesson, and we're going to be doing these questions. So let's get started with example 1. It says f of x equals this function, find f of 1. So all I'm going to do is substitute in. So I get what 2 times 1 cube is 2 plus 1 is 3. I'm just going to yep. So my point would be what? When x is 1, my y is 3. F prime of 1, so let's first take the derivative. I need to find the derivative of this, which would be 6x square. And now I want to do the derivative of 1, so which would be 6 times 1 is just 6. C, it says f inverse of 3. So this is where I want you to pay attention to, right? My original point was 1 comma 3, right? So if I do the inverse of 3, wouldn't it be just 1? I don't have to even find my inverse. I can just switch them, right? So now I want to do the f inverse prime of 3. So what is the rule? It is 1 over f prime of, what's the point? This is the, remember, this is the original. I'm going to write that down. Original y. So what would, oops. So what was the original x? It was 1, so 1. So you already know the f prime of 1, which is 6, so it's 1 over 6. Okay, here, again, you'll be like, why could I not do it? First of all, you're saving a lot of time by just knowing it. And second, not always will be the function given to you, or not always will it be so easy to see. So you need to know the rule. So example 2, it says f of x and g of x are inverses. So it's giving us the f function, and it wants to find g prime of 3 over 2. Remember, this is your y. So this is your y, original y. I'm going to write original y each time. So you don't know your x here, right? So can you find your original x? Yes, you can. How? If I substitute 3/2 actually for y, which is this, and solve for x, can I not be able to find it? So I'm going to actually set 3/2 equal to 4x cubed plus 1. So now if I solve that, what do I get? I get a half equals 4x cubed, and this would be 1/8 equals x cubed. So x would be cube root of 1/8 is 1/2. So x is 1/2. So that's how I got that, right? So my point, my original point, I like to write it down always. This is my original point. I want to find this. I'm going to write what I want to find, and then based on that, I'm going to find the remaining. It's 1 over the prime of the x. So do I know my derivative? No, I don't know of f, so I'm going to find that. So first I need to find the derivative of x, which would be 4 times 3 is 12x squared, right? Now I want to find the derivative of at what, 1/2, which would be 12 times 1/2 square, which is going to be 1/3. Oh, sorry, 3, not 1/3, 3. That's 1/2, right? So now I'm going to take this here. I'm going to change color. So it's going to be g prime of 3 over 2 is 1 over 3. And that's your answer.